Hello, and thank you for joining us for today's webinar, 7 Ways to Take Advantage of Additive Manufacturing. My name is Sharon Steinhoff-Smith with Stratasys, and I'll be your host for today's event. For those of you who aren't familiar with our company, Stratasys makes additive manufacturing systems that produce prototypes and production parts directly from 3D CAD files. Using our patented fused deposition modeling technology, our Dimension 3D printers and Fortis 3D production systems are the most widely used additive manufacturing systems in the world. We also operate Red Eye On Demand, an online rapid prototyping and digital manufacturing service. In today's webinar, you'll learn how additive manufacturing can dramatically impact not only your product development cycle, but also how your company functions. You'll see benefits in labor reduction, handling of goods, and tooling. From parts and tool storage to quality measurement fixtures to labor reduction through custom tooling, additive manufacturing can lower your company's total costs dramatically. I'd like to welcome our speaker today, Patrick Gannon. Patrick is the Manager of Engineering at Togus Products, Inc., an injection molding and manufacturing company based in Cleveland, Ohio. Patrick has a degree in mechanical engineering from Case Western Reserve University and more than 15 years of engineering experience. His work includes material handling, large metal fabrications, and metal-to-plastic conversion projects. Take it away, Patrick.
Thank you, Sharon. As Sharon said, I'm the engineering manager for Togus Products in charge of additive manufacturing. And I'm here today just to tell you a little bit about how our company has used additive manufacturing to increase efficiency throughout our plant. Togus Products is traditionally an injection molding company. But in the last couple of years, we've started taking advantage of additive manufacturing in a bunch of different ways. Everyone uses it for prototypes. That's something that I think everybody's familiar with. But we're here to talk about some of the other ways that we've found to use the technology. Togus was founded in 1950 as a tool shop and gradually started moving into actually injection molding. We concentrate on custom injection molding, and we run 24/5 most weeks, occasionally 7 days a week. We have around 86 employees, 76,000 square foot facility, which includes 35 acres, so we have plenty of room to expand. Located in Avon Lake, Ohio, we are ISO certified, include 28 injection molding machines from 25 up to 720 ton, which includes both vertical, horizontal, and two-shot capabilities. Relative to other injection moldings, we're about a medium-sized company. We run about $15 million a year at the present time. The processes that we focus on that we specialize in are insert molding, overmolding. We do some ultrasonic welding of parts, heat staking as a post-process, decorating, PVD and electroplating. We do some painting of parts. We do a lot of contract manufacturing, assembly, and we do some custom packaging as well for customers. Markets that we focus on, we try not to focus too much. I'll talk about this a little bit later, but we try not to focus too much on any one industry. Some of the markets we are in: life sciences, medical and pharmaceutical, food and beverage, fluidics, hydraulics, consumer goods, telecommunications, industrial, lawn and garden, and agricultural. We were in the late 90s about 60% automotive. And like I said, we try not to focus now, but at that point we were fairly well focused on automotive just like everybody else. But a decision was made in 1997, 98 to get out of automotive, and obviously that turned out to be pretty good for us. We've come through this recession fairly well because we've diversified so much in who we service. The problem that our management saw, there's 100,000 plus molding machines in the USA run by 8,000 processors. Once you're classified as a processor, you're just one of 8,000. That overcapacity in the market just takes away our value. You become a line item on a spreadsheet with 20 other molders, and this is one of our lines. The biggest winner is the biggest loser, and what that means is the person who wins the most contracts is the one who's cutting their prices down the most. You're your profit margins become very minimal. So we were looking for some way to differentiate ourselves, to get out of this, to get off of this line that we found ourselves on. So our solution, we came up with a variety of different things in order to meet this problem. One was engineered materials. We run everything from glass-filled, carbon-filled, tack-filled, up to a tungsten-filled material, which is used in shielding lead replacements. We do prototype design. This is important prior to tool build to validate 3D data. We focus on low to medium volume production. Instead of running one machine for days on end, we actually run 3 to 5 changeovers per week within our injection mold machines. This is very atypical, but it allows us to do this sort of custom smaller runs that people are looking for. We also focus a lot on metal to plastic conversion. This is something that's big these days, getting out of metal machining and metal processing. We also started looking at the rapid prototyping process in a variety of different ways, and this led us to FDM. Now, we brought this in again to provide a service for our customers, but we found a bunch of different uses for it within our shop that I think you'll all find very helpful. And that leads us into our seven ways to use additive manufacturing. So the 7 ways that we are presently using additive manufacturing in shop to help our production capabilities. You can see a number of things here that we do. The safety indicating fixtures is something that reduces operators from having to reach into the tools. It also prevents operators from having to hand cut gates off of parts. If you don't understand what the gate is, that's where the plastic is injected into the actual cavity of the tool, and there's usually a vestige left that needs to be removed before shipping out to the customer. So these safety negating fixtures reduce that hand, the necessity to locate the cutter by hand. You drop the part into the fixture, press the button, and it cuts it for you. We use these for drill guards. The drill guard you see here on the upper right, prior to having a guard in there, the operators are actually reaching their hand under that drill while it was still spinning to remove that part. Because these parts are going into a food processor, we weren't allowed to leave fingerprints or anything like that, so they were wearing gloves. So it became a very dangerous situation. So we designed this custom guard to fit around that, so they can no longer do this. Or if they do happen to slide their hand under there, the drill is up above that guard, so they can't come into contact with the spinning drill anymore. On the bottom left, you see diverter chute funnels. We use these for cavity separation, and you'd think, yeah, why don't you just put the pipe? But the parts had a tendency to fall all over the floor, which is no good. We use these to separate cavities in multi-cavity tools. That could be up to 2, 4, 8 cavities. We use these for. And what that does to help us is if there's any issues with any of the individual cavities, the operator or the quality manager, whoever, doesn't have to go through every single part. They're separated by cavity, so if there's an issue in one cavity, they only have to go through the parts from that specific cavity, or they can just separate them out if it's a bad shot. And on the bottom right there is another safety guard, but it's also a part of an automated ultrasonic welder. So this is something that we run this quite a bit, and it became very tedious loading these and unloading these individually. So we came up with this rotary table, and we saved something by designing and manufacturing with additive manufacturing. In this one in particular, I think we saved somewhere around $20,000 or $30,000 on the manufacturing costs. The 5S program. If you're unfamiliar with this, 5S basically means there's a place for everything and everything has a place. So when you go to look for a drill bit, the drill bit is always in the same place. No matter which toolbox you're looking at, it's always in the same place. It's always located in the same place. So some of the ways we've used this in our plant, the nozzle tips in the upper left there. Every one of our machines has one of these small fixtures attached to it that has nozzle tips used in that machine. So when an operator needs, you can see their nylon general, and there's different hole sizes. So when they need a specific one that's used on that machine, it's always right there. They don't have to go looking through a bucket of 500 of these things. It's always sitting right there in front of them. The knockout rod holders is another thing that we use in the assembly of tools, and that's, again, mounted on the machine. There's a couple different sizes, and they're always there, right there, where somebody can just reach out and grab them. Scan guns, we use this for moving materials and parts around the shop. So what this does, these scan guns cost several $1,000s each, and they had a tendency to be set down and just left, and nobody knew where they were. That's not fun when you have a scan gun that costs a couple grand. So these holders are located around the shop, and the scan guns are always placed back into these holders when people are done with them, and it prevents them from getting lost, and it prevents people from having to walk around looking for them. Quality measurement. These fixtures for our OGP, which is optical gauging products. This we use to measure dimensions. We do dimensional layouts of the parts. What we've done with this is you create a fixture that holds the part specifically, and it's broken off into cavities. And again, you place this on the OGP, and you set up a program, and you can just walk away and let it run, and it does all the measurements that are required. This saves, in terms of operator, this saves hours of time where they don't have to sit there measuring individual parts. And again, you can do this with traditional methods of machining, but for us, the cost to do this is minimal. Once you have the machine in-house, you're talking about material, which is essentially nothing. I should say relative. It's essentially nothing relative to machining out of aluminum or something like that. Factory efficiency and automation. Almost all of our end-of-arm tooling, which is used to remove parts from the injection mold tools, almost all of our tooling now has at least some components that are made out of additive manufacturing. Upper left is I believe that's 16 cavity tool that the parts were so close together that traditional means never would have been able to place the grippers close enough to pull the parts out. So we made the plate on our FDM machines, and the next day it was ready to go. On the upper right, you see a tool that we were able to create the part exactly to the shape. I should say create the tool exactly to the shape of the part. When it goes into the injection mold tool, it wraps around the part and is able to pull it out. Bottom left, these are adjustable conveyor gates. So when you're dropping our conveyors are standard size, but our boxes are not. We ship in various size boxes. So as the parts are coming off the conveyors, we want to funnel them down into the size of the box that they're meant to go into. And this allows us to do this very easily. And the attachment pieces on the end can be customized to the different conveyor styles. And you can see the bottom right as well, where we have very small parts going into a small box, and we're able to funnel those down to that size. We also use this technology for assembly fixtures. In the case you see here, we use the push washers into a tube fitting. The fixture holds the fitting in the base, and the top is mounted into an arbor press that, when pushed down, presses the washers down into the fittings. This is not really a difficult task, but it gets hard on the fingers when you have to do it over and over again. Plus, it's very slow by hand. By using this fixture, we can do 4 parts in less time than it takes to do 1 by hand. And obviously, this is a good thing for the people on the floor and for our scheduling. This is just one way that we use technology on our shop floor to make things easier. And obviously, this is more traditional, the customer samples. So a customer comes to us with a design. We can print it for them and hand it to them so they have it in their hands if this isn't something that they do in their design process. And we've done this for customers where they've found errors. We've handed them their assemblies, and they've found errors in their assembly and made the changes. And in one case, we were actually able to print that during lunch and have it after lunch was over. So in a metal to plastic conversion on the left, we printed their parts out. I think that's a 12-piece. There's 12 of those that go into an assembly. Made the 12 for them. They assembled it, tested it, and they've validated their design that way. On the right, the customer gave us a part that was what we call die locked, which means the part for some reason can't be pulled off the tool. In this case, it was because there was an overhang as well as a screw. So in order to get out of that screw, you need to turn, but in order to do that, you had to get past the overhang, which wasn't possible for us to do. So we redesigned it with an insert, and we were able to do that redesign quickly, print it up for them in 2 pieces, and show them what their final design would look like, which ended up being that clear piece on the left of that. And that job actually we won because of the FDM parts we provided to our customer, and that essentially paid for our first machine by getting that job. And one of the biggest things is employee innovation. You can see here a couple of designs that we've done basically just for fun around our shop. If an employee has an idea and they want to make it, the machines are open to any employee for anything they want to try. On the left, every employee has a business card holder, and it also holds just about any smartphone. It also holds iPads as well as any other pad of similar size. So you can sit this on your desk, your card's facing out with your name and title and company on it, and you can be looking at your phone at the same time. And on the right, just some fun table design that we did that sort of incorporated a logo. That the swirling circles are part of a logo. That was just a fun table design that's sitting in one of the lounges we have in our shop. What this does too, it enhances this sort of culture of innovation that people, they think of an idea, they can see it, they can make it, and that just kind of fosters these ideas. It makes it easier to make ideas happen, I guess you could say. So the economics of this, what we've found in our automation is we're saving somewhere on the order of or greater than $150,000 a year by just making these parts ourselves, designing and making these parts specifically for jobs ourselves, as opposed to going out and having somebody design and machine them in the traditional manner. We shorten lead times for product development. Like I said, that the one customer design, we probably shortened their design cycle by months because they didn't make a tool that wasn't going to work. And in the end, we're done competing with the 8,000 molders. We can support them. They want end-of-arm tooling, we can do that for them. They want quality fixtures or assembly fixtures, we can do that for them. But in order to do that, what we needed to do was create a new company. We don't want them to see us as a competitor. We want them to see us as a supplier, as a partner. So we created a company called Rapid Prototyping Manufacturing, or RP+M for short. So what RP+M is a traditional prototyping shop. We also provide product development, regulatory support. We do material research, which is very important for particularly our medical customers. And we provide help in selection for application and compatibility. We have design assistance validation and a bolt-on engineering group that focuses on design for manufacturability. clients that we have in this division are OEMs, obviously, product development companies that don't necessarily make anything, but they're working on designs for their customers, industrial design firms, other plastic processors, tooling companies, fabrication shops, and then your everyday average Joe who has some idea that he thinks is going to become something. We actually had one of these in our shop recently who was 7 years old, who won an invention contest, and we brought him in, modeled up his part, and let him start the machine, actually printing his part within an hour of his arriving at our shop. So that's going to be done. That was finished and sent off to him the next day. So what we have become, based on this innovative culture that we're trying to really push in our building, is this conglomeration of two companies, which includes 15 engineers from a variety of different disciplines, including biomedical, plastics, chemical, mechanical, industrial, electrical, and we even have a civil engineer. So what we're becoming is this passionate group that love to help our clients to innovate and to provide this innovation within our own shop. And we love to have fun. You can see from some of the designs, like the table design, it's just something to have fun that we enjoy doing. And with this technology in-house, we're able to do that quite easily. The technology we have is, at this point in time, we have Stratasys FDM equipment, and we have pretty much their full range, the U-print dimension, 400 and 900. And we have the smoothing station, and we have all the materials that are available through Stratasys, the various ABSs, the PCs, Ultem, polyphenol, sulfone. This is our lounge. You can see we've tried to create this comfortable area where people can go. They can bring their laptop in here, sit, work on their designs, meet with customers. It's a great place to bring people into. We've got demonstration parts all over there, the tables, multiple tables that have been printed, and it's just a fun place to bring people into, to sit and talk about what we can do for them. And that is our story. I hope you've learned something helpful and can take that back to your own shops. And I'd be happy to take any questions that you might have about what I talked about today.
Great. Thanks, Patrick. In just a minute, we'll take any questions that you may have. If you think of a question in the meantime, be sure to submit it through the chat panel. I also wanted to let you know that after our event today, you can find this recording. You can request a sample part and download some other relevant materials at the website that you see on the screen. It's stratasys.com/manufacturing. Okay, it looks like during the presentation a couple of questions have come in that we have some time to take live right now. There's a question here from Don who asks, capital equipment is always a big expenditure. Patrick, how did you justify the purchase of these machines?
That is obviously very important. Like I said, we actually essentially paid for our first machine with one customer, one product. Obviously, that's not going to be the story every time. With us, obviously that helped. We saw it as, when we first started purchasing the equipment, we saw it more as a value add for our customers. We can give them parts, we can quote them and hand them their part, we can show them what's wrong with their part. That's something, again, that we were trying to differentiate ourselves from other customers. But in terms of the payback, you saw in terms of our automation, $150,000 a year. You haven't paid for all the materials, but at that point, you've paid for the machine right there. It's something you have to look at within your own shop, obviously, but for us, it's been basically a no-brainer bringing this equipment in.
Okay, great. Here's another question that came in. This one's from Nick. He says, I'm not an injection molder, I'm a blow molder. How could this impact my business?
Blow molding is similar to injection molding in that you've got parts in a tool that you have to remove. So, and I'm sure you've got robots You can shape your end of arm tools to any shape you want to remove parts from the machines. But I also know we do a little bit of this in injection molding as well. But I know it's something that you can do in blow molding too. Is you can create tool cavities for short run prototyping, whatever. You can create tool cavities that you can use in the blow molding process. We've done that, like I said, with injection molding, and we've injected basic materials up to the tungsten filled polymer that I talked about earlier. So it's something that on that side you can actually provide that service to your customers, where you don't have to wait 4 weeks for a machine tool to come in. You can print a tool overnight and be making parts within days.
Great. Looks like we have another question. This one's from Janice, and she asks, could I do these same things with SLA?
You could do some of these things with SLA, but you're not going to get parts that are going to last. The parts coming off of these FDM machines are real thermoplastics. They're hard, solid, strong parts. One of the demonstrations I like to do for customers that come in when they ask if are these parts strong, because they're used to dealing with SLAs that crumble and fall apart and can't handle any kind of stress. My favorite demonstration is to take one of the parts and just throw it across the room, because these parts will survive. And when you're particularly in a manufacturing process, you need strong parts.
Great. Thanks. Patrick, I have one last question for you, and I'm going to put you on the spot. Where do you see this going with your business in the future, 5 to 10 years out? How do you think TOGAS and RP&M is going to be different than it is today?
TOGAS and RP&M will be different, yes. Very, very different. We see more and more culturally, technologically, as a culture, we're moving more towards specification. We want something custom. With traditional injection molding, you can't really do that. You're never going to eliminate that completely, because you're always going to have millions of automobiles coming off an assembly line. But more and more people want things customized specifically for them, and we see that being a bigger and bigger business as time goes on, and that's where additive manufacturing is going to be important. Or it's like I said, it's never going to replace it, but it's going to be on par with it, we think, within 10 to 15 years at the most.
All right, great. Thanks, Patrick, and thank you all for your questions. If we didn't get to your question live on the call, we'll follow up with you via email. We'd like to thank each of you for your attention during the presentation, and now I'll turn it over to our operator, who will close out the session.